Hello, guys. Let's talk about brain cancer. Specifically, we are going to be looking at gliomas, which are a type of brain tumor. But before we get ahead of ourselves, let's just backtrack a little bit because there is a lot to cover. So, we all know about cancer, presumably. We've all heard about it. It is very deadly and very widespread in the modern era. Now, cancer research and our overall understanding and ability to treat the disease has just come so far over the years. And, we know so much more about it now, and treatments are only getting better. And getting a stage 4 cancer diagnosis, maybe at one point, could have been like a death sentence. But I think now, with the right technology and the right innovations and, just knowing what cancer actually is, I think there is a lot more hope for survivors and for being able to get on the path of recovery after a cancer diagnosis. And while, of course, justifiably and rightfully so, cancer is still a terrifying disease that takes millions of lives each year. Globally, there were an estimated 20 million new cases of cancer and 10 million deaths from cancer just last year alone. However, again, I would like to be optimistic and say that, things are improving and things are looking good for our future. Cancer mortality rates appear to be on the decline. And with constant discoveries and constant innovations and the wonderful work that our scientists are doing right now in cancer research, we have been making, slow but undeniable progress in our fight. Now, as a quick little review, cancer is a disease that is caused by gene mutations, and these mutations result in cells dividing uncontrollably. So cell growth is dangerously uninhibited. And so this cancer then begins to invade and destroy other tissue. Now, many cancers will cause tumors to form in the body, and tumors are abnormal growths or lumps because, again, these cells are multiplying rapidly, so they just bunch up into what we call tumors. These tumors have the potential to spread or metastasize to other parts of the body. And at that point, we call that advanced cancer or stage 4 cancer, when your cancer has spread to multiple parts in the body. Note that not all tumors are cancerous. Malignant tumors are symptomatic of cancer, but we also have benign tumors, which can form from not cancer. And they're usually slower to form. They don't really metastasize. They don't really move around. And they're usually not problematic, so you don't really have to worry about them as much. So these cancerous tumors can show up almost anywhere in the body, from your lungs to your blood to your bones, etc. And the label of the cancer is dependent on where the primary tumor formed, so where the very first tumor was found in your body. So if the first tumor occurred in your lungs, then that's lung cancer. But today we are going to focus particularly on brain cancer. Now, brain cancer is a little bit different. Tumors in the brain will almost never spread beyond the nervous system. So the tumor, if it's in your brain, it can move around to other parts of your brain, move into your brain stem, but it cannot metastasize beyond that. So you can't have a brain tumor go into your kidney, for example. However, they can still be especially problematic for a few reasons. Cancer in the brain can lead to a whole host of symptoms because obviously it's damaging the very thing that controls your entire body and tells it what to do. So there are so many incredibly scary symptoms. This includes headaches, difficulty moving, weakness, fatigue, sensory issues, sensory loss, personality changes, blurry vision, seizures, and the list goes on. Additionally, brain tumors are very difficult to treat. The brain is a difficult place to access if we're trying to do some invasive surgery and trying to get the tumor out. It's not easy. You have to drill through the skull and make sure you're not damaging parts of the brain that you don't want to be touching, right? And cancer, when it gets to the brain, can be very, very complex, and it can affect so many different things, and it's a lot to manage. Because, you're squishing with bits that God meant to stay tucked away, right? And on top of that, there are many different types of brain cancer. There are 120 different types of brain tumors according to the National Brain Tumor Society. But today, we are going to focus on just one type of brain tumor, gliomas. And I know I keep putting out more categories and even more specifics, and I'm going to focus on this, but I promise you we'll get to the end and we'll figure it all out together. So gliomas are the most common type of central nervous system tumors. They make up 26% of all primary brain tumors and 81% of all malignant brain tumors. According to the National Organization for Rare Disorders, gliomas develop in 6.6 per 100,000 individuals each year. All right, great. More fun science hippie words and numbers. But what the hell are gliomas? Well, gliomas are a type of tumor that occur in the glial cells of the brain and spinal cord. And what are glial cells? Well, in your brain, you've got your nerve cells, your neurons, and these are the ones that are, actually doing the brain stuff, right? They're sending electrical signals around, telling you how to feel, emotions, memories, how to move, how to do things, whatever. Glial cells are supportive cells in the nervous system that are there to help insulate and provide nutrients and support the neurons, as well as remove waste from your nervous system. So, gliomas are further classified based on the type of glial cell involved and the level of malignancy of the cancer. So gliomas are graded, right? They're graded on a scale from 1 to 4, grade 1 being the least aggressive and grade 4 being the most aggressive. Grades 1 and 2 are going to be what's called low-grade gliomas, and those are benign, so they're not really cancerous. But grades 3 and 4 are when they become malignant or cancerous, and they become, super fatal. So, the symptoms and severity of gliomas greatly vary depending on the tumor's size, type, location, and grade. And actually, the 5-year survival rate of people diagnosed with gliomas can range anywhere from 95%, which is really good if it's a really chill grade 1, to 5% if we're dealing with a really aggressive grade 4, which is crazy. So, again, there's a huge variance here, and because of this variety of factors, treatment plans for gliomas can vary as well. And there are different treatment methods, of course, one being surgery, which involves removing the tumor or portions of it from your brain physically to get rid of symptoms. Radiotherapy, which is just blasting beams of energy to try to kill off the cancer cells, or chemotherapy, which is pumping you full of deadly chemicals to, again, try to kill the cancer. But before we can even get into all that, before we can get into treatment plans, the most important step is detection and proper diagnosis. We can't fix if we don't know the problem. And so, a great way to do that, and a very important step, is MRIs. All right, so remember those gliomas. We're going to tuck that away. That is the first layer of the project. The next layer is MRI, or magnetic resonance imaging. This is a non-invasive imaging technique used to visualize detailed internal structures of the body, especially soft tissues like the brain. So perfect for brain tumors and really getting a look at what's going on. So they do MRI, they do this imaging with these machines, MRI scanners, which essentially is just big, huge magnets that are really strong, and they're just playing around with magnetic fields and seeing how your body's atoms dance around and react to it. But a detailed description. So when a patient lies in the MRI scanner, they are exposed to a very strong magnetic field, and this field aligns the protons in the body's hydrogen atoms, and they all start to face specific directions. Then, short bursts of radio frequency pulses are then applied to the patient, knocking these protons out of alignment. When the radio frequency pulses are then turned off, the protons realign with the magnetic field, emitting radio signals, emitting energy in the process, and these signals are detected by the scanner. Then after that, we're going to reconstruct the image. So the emitted signals are processed by a computer to construct detailed images of the body's internals. Okay, great. So now we have these images. We can, see the tumor. We're good to go. Well, there are still a few challenges in the way for this MRI diagnosis. The first thing is the volume of data. MRI scans can generate just a very big amount of data. and that can be time consuming for radiologists to interpret. Another thing is subtle differences. Gliomas can present very minute differences in MRI images that are difficult to discern with the naked eye. And the final thing is that there is a lot of variability in MRI images due to differences in equipment, differences in scanning protocols, and patient anatomy. And so even though MRIs are great, very useful, there is still plenty of room for error. Okay, so how do we fix it? Well, that is where the last layer comes into play: machine learning. Now, AI and machine learning is a rapidly expanding field that is really just affecting everything that we know today. A lot of different fields are being changed up by AI, and medicine is no different. Now, of course, it is not without its controversies, but today we are seeing more and more responsible applications of machine learning models in assisting doctors, contributing to research, and improving patient outcomes. In this specific case, machine learning algorithms can be trained to automatically segment brain structures and identify regions of interest, for example, tumors, reducing the manual workload on radiologists. And with the precision of a computer, it is possible to reach even more accurate diagnoses than possible with just a human. Machine learning algorithms provide consistent and reproducible results, reducing the subjectivity and variability inherent when we're just working with human doctors. So, with this in mind, I decided to try to make a program myself that would assist in reducing the margin of error for glioma diagnoses. To do this, I would have to use a CNN, short for convolutional neural network, a type of artificial neural network that uses algorithms to analyze and filter through and identify visual features in large amounts of data. Again, perfect for what we're working with MRIs. Now, after training my model on the BRATS-20 glioma patient dataset obtained from Kaggle, we are able to achieve a program that can successfully identify and predict high-grade versus low-grade gliomas. Let's take a look. Here we enter into the home view for Heka, a glioma detection engine that I've been developing for the past week. Now, as a doctor, you have access to a directory where all your uploaded patient files are displayed for you to select from. For this project, we will be choosing patient number 6. Next, we enter a particular X, Y, and Z cross-section of the MRI image that we are interested in. From here, the engine reads your patient's MRI files and begins visualizing the brain scans for you to see. Here we can see both an external view of the patient's whole brain, as well as an internal view into the particular cross-section we selected previously. Finally, the engine analyzes the patient's data and makes a prediction of whether or not the patient has a high grade, grades 3 and 4, or low grade, grades 1 and 2 glioma, displaying a visualization of both the prediction and estimate of its accuracy. So, while this is still a rough program, I think it has the right idea. When we're looking at artificial intelligence in the modern world and, the ethics and how we're going to use it moving forward, we have to think of it as just another advanced tool that is being added and developed in our arsenal as a society. Now, this tool can be used incredibly negatively to harm and detract from the world, of course, but also wonderfully in very substantial pursuits, in pursuits of helping each other, in pursuits of, lengthening life and improving quality of life, improving the beauty of life. AI inherently is not good or bad, right? It is how we decide to move forward and apply it that will truly define it. And of course, my little project is not going to, solve brain tumors forever, but hopefully things like this are going to be a step ahead in the right direction. And hopefully humanity will decide on what's right. Thank you so much for watching and take care.